Hello, Algebra 1 students. Mr. Ford here with another homework tutorial. This is 532 Part 1. It's actually Part 2. Whoopsie. Oh, oopsie poopsie. 107 through 110. Let's go ahead and jump into it. We got a bunch of equations to solve right away. All of these are review of former types of equations that we've solved before. For question A, what we're going to want to do is bust out your old generic rectangle tool. Or if you like, you don't need this. You could just multiply and you know how to do it, but we have x plus 2 and x plus 3 that we're multiplying, and if you multiply them together, you get x squared, you get 6, you get 2x, and you get 3x. If you add all that together, you get x squared plus 5x plus 6, which equals x squared minus 10. The nice thing about this is that you can now remove x squared from both sides of the equation and be left with a pretty simple problem. 5x plus 6 equals negative 10. Of course, you still have to solve it. You have to subtract 6 from both sides and get 5x equals negative 16, and then divide by 5 to get a final answer of x equals negative 16 over 5, and there you go. Question B. This is one of those fraction problems we dealt with on a checkpoint quiz a while ago. In this case, what makes this problem really hard is the denominators are all different, so let's make them go away. If you look at 2 and 3 and 6, looks like the least common multiple is 6. 6 divides by all of those things, so we're going to multiply everything by 6. This will give us 3x for 6 divided by 2. It'll give us 2x for 6 divided by 3, and it'll give us 42 for 6 times 7. And then over on the very far side, the 6's actually cancel out, and you're left with 5x. So after combining our like terms together, what we'll have is 5x minus 42 equals 5x, which actually has no solution, because if you subtract the 5x from both sides, they cancel out, and you get negative 42 equals 0, which has no solution. Let's look at question C, where we have an absolute value problem. What you got to remember about absolute value problems is that 2x minus 1 is an operation that you're going to take the absolute value of. Now, this could equal 9, or it could equal positive 9, negative 9 or positive 9, and either way, the absolute value of that would be positive 9. So we need to solve two equations. We're going to take 2x minus 1, and we're going to write it down 2 times, put an equal sign after both of them. One of them equals 9, and one of them equals negative 9. We're going to solve these problems side by side at the same time because they involve the same steps. We'll start by adding 1 to both sides in both equations. We'll get 2x equals 10, and 2x equals negative 8. And then we will divide by 2 on both sides, which cancels the 2 out and leaves us with x equals 5, or x equals negative 4. Those are our two possible solutions. There we go. And finally, we got another fraction-y kind of problem. This one is best solved by a process called cross multiplication, which is the same thing you would do normally if you just multiplied by 6 by everything if you wanted to cancel out the 3 and the 2. You'd end up getting the same answer. Cross multiplication works like this. We're going to take 3 and multiply it by x to get 3x. And we're going to take 2 and multiply it by the quantity x plus 1 to get 2 times x plus 1. You have to remember to put x plus 1 in parentheses there, though, too, because it's its own little thing. And then you can distribute the 2. You'll get 3x equals 2x plus 2. And when you subtract 2x from both sides, you'll get x equals 2, and that is the answer. Which kind of makes sense, because 2 plus 1 is 3, and 2 over 2 is also 1. So you get 3 over 3 equals 2 over 2, which is totally correct. Okay. For 5108, we got each sequence is defined recursively. We're going to write the first 5 terms and then define it explicitly. So we're going to do both those things. Let's start with the first one. They tell us the first term is 12, so I know the first number is 12. And they tell us you get the next number by taking the current number and subtracting 5. So the next is the current minus 5. So the next number will be 7. After that would be 2. After that is negative 3. And after that is negative 8. And then there you go. Dot, comma, dot, 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 dot. That's the sequence. As far as the explicit sequence goes, well, there's a couple different ways to write it. I'm going to show you two. Normally what we would do is go back in time one step to 17. We'd go back in time and do 17 minus 5n. That is probably the most straightforward way to do this. Minus 5 is the slope, or the common difference in this case, and 17 is the 0th term, where you would usually start. Now, if you don't like 17, you don't like finding 17, what you can do is start at 12 and subtract 5 times n minus 1. That works also. So it's kind of up to you how you want to do this. For question B, we have a very similar thing. It's all just the notation is a little different, and it's going to be kind of a different sequence too. In this case, they told us the first number is 32, so the first number is 32. And then again, they told us that the next number is 1/2 times the current number. So we're just going to multiply by 1/2, which is another way of dividing by 2. That gives us 16. And then we get 8, and then we get 4, and then we get 2, and then 1, and then 1. And I guess we only needed the first 5, so we did more than we needed to. There you go. Now, this is not a linear sequence. This is an exponential or geometric sequence. So when we write it, it's going to look a little funky. But I'm going to use this notation here. I'm going to say that a sub n equals. We're going to write an explicit sequence for this. Now, you can do the exact same thing we did last time. Go back in time one step to 64. Let's take 64 and multiply by 1/2 to the nth power. That's the big difference, is that I usually put the 1/2 in parentheses like this. But the idea is we're taking 64 and multiplying it by 1/2 to get 32, and then might have 1/2 again to get 16, and so on. So this, if I want to know the 10th sequence, I just have to plug in 10. You can do the exact same trick, by the way. Start at 32 and multiply by 1/2 to the n minus 1th power. That works also. Just a little handy trick there. That works too. Okay, let's talk about parallel to negative 2/3 x plus 5. This has been showing up on circuit trainings, and I guess this is the first time we've kind of talked about it. Parallel lines, here's the thesis of this problem. Parallel lines have equal slope. So the slope of this line is m equals negative 2/3. So what we're looking for is which one of these equations has that slope of negative 2/3. You'll notice that none of our choices are in y equals format, so kind of the challenge is to put them into y equals format. Now, if I was going to do this first one here, I would subtract 2x from both sides, and I would have negative 3y equals negative 2x plus 6. Kind of scrambling for room here. There's not enough room, but actually there's enough room, because here I can tell you that this is not it. Because the next step would be to divide by negative 3, and here I have negative 2 divided by negative 3, which is positive 2/3 and not negative 2/3, so you're out. Question B, if I subtract 2x from both sides, I will have 3y equals negative 2x plus 6. And then if I divide by 3, there it is. I'll have negative 2/3. And that is the slope we're looking for, negative 2/3. So I believe that B is the correct answer. Let's check the other two. Here, if I subtract 3x from both sides, I'll get negative 2y equals negative 3x plus 6. And that ain't it, Chief, because if I divide by negative 2, I've got negative 3 over negative 2, and that's not the same slope. And over here, if I subtract 3x from both sides, I'll have 2y equals negative 3x plus 6. And when I divide by the 2, I'll have negative 3 over 2. And that's close, but we need negative 2 over 3. So it's B. B is the correct answer. Just like that. Again, I'm going to point out, look at all the work you got to show. This is not about circling B. You got to know why it's B, my friends. Let's look at the last question here. 5.1.10. The graph at right shows a comparison of the length of several gold chain necklaces, including the clasp, to the total mass. Oops, my thing froze on me for a minute. So what we're going to do is we're going to write an equation for the line of best fit. We're going to write an mx plus b. The nice thing about this equation is that, honestly, there's a lot of different answers that are acceptable, so let's just make one work. Now, I have a fancy ruler on my tablet. You probably don't have a ruler handy, but, you can just eyeball this pretty well. It's okay. Now, I'm going to be honest with you, I explicitly chose my line to go through 4 right there, because this tells me that the y-intercept is 4. You know, as far as the slope goes, this is going to be really, really tough to find because there's not a grid on this. So I'm just going to kind of eyeball some points. That looks like the 0.48 to me. You know, is that the 0.812? I'm going to call it the 0.812. I mean, this is all a very rough estimation anyway, so I'm just going to pick out a couple points that I think are on the line. It looks like 4, 8, and 812 are on there. That's a change in y of 4 and a change in x of also 4. So my slope would be 4 divided by 4, which is 1. And I kind of like that. 1x plus 4. There you go. So that would mean, based on my equation, what would I expect the mass of a 24-inch chain to be? Well, inches is the x. So I'm going to go down here and do y equals 26 plus 4. And I would expect the weight to be 30. And that would be in grams, 30 grams. And there we go. Hey, I hope you enjoyed this homework tutorial. I will see you in the next one. Don't forget, you are awesome and you are good at math. You can do this.